What's wrong?
I don't know. I don't know. Everything's here. Can't get a bag. I'm gonna figure out. Oh no.
I don't know. Let's see. Um, what can we remember about exponential functions? Do you guys remember what the equation looks like?
Y equals a times b to the
Perfect. Y equals a times b to the x. And what does a tell us? The starting amount. Starting amount. And what does b tell us? Very good, the common ratio. And do you remember what we said we used for x? Yeah, time. And then sometimes it'll be, instead of time, it'll be like a term number, right? Like find the 10th term. So it's going to be time or term number. Good. Okay. And there were two different types of exponential equations that we looked at yesterday. What are the two different types? Perfect. Yeah, there's growth and decay. What's the difference between growth and decay? Yeah, one is increasing and one is decreasing. So our growth equation looks like that, and our decay function looks like that, right? And there's a part of the equation, y equals ab to the x, that changes depending on whether we're looking at growth or decay. Which letter changes, A, B, or X? B, good. So B, for our growth equations, B is always going to be, thank you, B is always going to be greater than 1. And that's because to find B for our growth equations, we take 1 and we add on the growth rate. So that's going to be like usually a percentage. Okay. And so when I change my value for B to be 1 plus R, my equation changes a little bit. It's going to be y equals A times B, but B is 1 plus R, so A times 1 plus R raised to the x power. And then for decay, it's kind of just the opposite. For decay, my value for B is going to be less than 1, but greater than 0. So between 0 and 1. What's a number between 0 and 1? Good, 0.5. How do I write that as a fraction? 1 over 2. How do I write it as a percent? Good, 50%, right? So, good. Can you give me another number between 0 and 1? 0.75. What's that as a fraction? 3/4. And as a percentage? 75%. Good. So these like growth and decay rates usually involve some sort of percentage. And then when we're looking at growth, we're adding that like decimal or fraction or percent onto 1. So that's why the value of B is greater than 1. But for decay, what do we do to find B? We subtract R. And that's why it's somewhere between 0 and 1, right? And so my equation again changes a little bit and it becomes y equals A times 1 minus R to the x. Okay. Give you a second to catch up. Bless you, bless you.
Yeah. I'm not excited that I'm using something.
Yeah. All right, so let's look at these two examples. I'm going to do these two problems with you on this side of the paper, and then you're going to do the back on your own. So the first one, we have Kirsten, and she invested $2,000 into a CD with a 5% annual interest. Do you guys know what a CD is?
Yes.
Huh? Wait, what is it? What is that? Compact disc. And yes, there is a CD that can play music, right? No, CD. Someone else thought I said CBD. And
Oh, it's college.
yeah, we don't need to get into that. How did you know that? Very good, Kaya. Good job. Certificate of deposit. Do you want to explain what it is? Exactly. Exactly. So it's kind of like a bank account, right? Like if you have $2,000, right, you could just leave it in your piggy bank at home and let it sit there. But in 15 years, it's still going to be $2,000, right? But if you put it into a bank account called a CD, you put it in and then you have to leave it for a period of time. But then at the end of that period of time, you take it out and it's grown. It's become more. Mm-hmm. Yeah. And usually the time that you leave it in is a long time, like this, 15 years. And as well, the only other like negative side to it is that you can't access that money during that time period. You know, that $2,000, it's your money, but you can't use it during that time. You have to wait until the end of that period. So it grows. So this is interesting. And I didn't know this until just recently, and it really kind of blew my mind. So any type of savings account at all gains interest. And like a normal savings account in a bank might have like 0.5% annual interest rate. A CD is like special because, and it has that higher interest rate, but banks are able to give interest on your money because, so banks have like checking accounts and savings accounts, right? Savings accounts, right? If let's say, you know, I have a savings account, you all have savings accounts with a bank. That bank now has a lot of money, right? Like if we each put $1,000 in there, that's, you know, $17,000. Now what they do with that money is they don't just let it sit in the bank. They actually loan that money out. So you want to go and buy a car, you borrow money from the bank. Jamie wants to buy a house, she borrows money from the bank. Isabel wants to start a business, she borrows money from the bank. Now the bank is loaning you money and you guys are paying the bank back with interest. So part of that interest that you pay back to the bank gives back to the people.
That is so
You see what I mean?
cool.
Isn't that interesting?
That is really interesting.
It's kind of wild. And then you think about it, and this is part of like what happened during the stock market crash in the 1920s, was like it was called a bank run. So if the bank loaned a bunch of people money, and it's kind of related to the housing crisis that happened in 2008, the bank loans out all this money, and if people stop paying back the loans, and then I go to the bank and I say I want my $5,000 that was in my savings account, and they say, sorry, nobody paid back their loans, so we don't have your money. And like that's what they're, and that's like, it was on a much bigger scale and there was a lot of other things involved. but there was a housing crisis in 2008, and there was a recession during that time. Because of that, there were a bunch of people who had mortgages on houses that they couldn't afford, and they should have never been given. And so then eventually they weren't able to pay back those loans. And when maybe one or two people do it, it's not a big deal. But when everybody can't pay back their loans, what happens? It all kind of it's like dominoes. It all just kind of falls down. So it's not just that the market was cheap, it was that the people who were giving out the loans weren't taking the proper precautions to make sure that the people could pay back their loan. So when I bought my house and I got my loan, I went to the bank and they looked at all my bank statements, they looked at my income, they looked at any assets that I had, they looked at my car payment, they look at all these things to make sure that I'm able to pay back my loan, right? And I can't, right? I make $40,000 a year as a teacher. There's no way I can afford a $2 million house, right? It's not possible. So they wouldn't give me the money for that. But the way I understand it is in the early 2000s, they were allowing people to take out these crazy mortgages, and they had what's called, I think it's called a graduated mortgage. So they start with a low mortgage payment and then it increases over time. So maybe at first you could afford it, but then, and you hope you make more money in the future, but what if you don't? Then you're kind of just locked into this really high mortgage rate, and then a bunch of people just couldn't pay back these loans. So, yeah. There's a movie called The Big Short, and it talks about the housing crisis in 2008. It's a really good movie. They swear a lot in the movie, but it's really good, and they explain it in a way that makes sense. So I'd suggest watching it. It's interesting to you. Okay, let's get back to our CD. So she's putting the money into this CD. Does she want the money to grow or does she want it to decay? Grow, right? This is growth. This is growth. So I'm going to use my growth equation. Y equals A times 1 plus R to the X. Where again, A is my starting amount. So how much did she start with? 2,000. And what would be my growth rate? What is that? Good, 0.05. Uh-huh. Yeah, and we'll talk more about that in a second. And then what's the time period we're looking at? 15 years. Good. Okay, so again, my starting amount is 2,000. My growth rate is 5%. It's growing by 5% every year, but I need to change that from a percent to a decimal. And how do we do that? Yeah, just take 5 and divide it by 100, so that's 0.05. And then my time period is just 15. So now I can just go ahead and I can plug all those numbers into my equation. So I get y equals 2,000 times 1 plus 0.05, thank you, and then raised to the 15th power. So now it's just as simple as typing this into your calculator exactly as you see it, and you will get an answer. I'm going to come around and check your answer and make sure you know how to put it in the calculator. All right, so what do we get when we plug that in the calculator? Perfect. Perfect. You did. Good job. Very good. So again, right, she put in $2,000. If you just left that in your piggy bank, 15 years later, it'd be $2,000. But if we put it in a CD, it's going to double, right? It's pretty nice. Okay, and now we have Quinn and her motorcycle. And her motorcycle is valued at $15,000. with an annual depreciation rate of 25%. Find the value of the motorcycle after 5 years. So yeah, growth or decay? Decay. And what's different about our decay equation? Yeah, so we're going to do y equals a times 1 minus r to the x. Where again, a is my starting amount. That r is going to be my decay rate. And then x is the amount of time. So what's the starting amount? Good, 15,000. What is the decay rate? 25%, but how do I rate 25%? Huh? Good, 0.25. And what's the time limit, or the time that we're looking at? 5 years. Good. So again, y equals 15,000 times 1 minus 0.25 raised to the 5th power. And one more time, can you please plug that in your calculator and show me what you get? And then you can start working on the back. And there's some problems like what we were doing earlier this week, as well as problems like this, as well as some more complex. You don't like that word?